Welcome to my channel. We have given a problem of IIT 1991. This is very important problem for JMIN 2024. So we are going to discuss the solution of the given problem. We have given definite integration problem from 0 to pi x sine 2x sine pi over 2 cos x over 2x minus pi. So first of all, take 2x minus pi is equals to y. Differentiate with respect to x and y, we get 2 dx is equals to dy, and this implies that dx is equals to dy over 2. Again, at x equals to 0, we are going to find out the value of limit. At x equals to 0, so y is equals to minus pi, and at x equals to pi, y is equals to pi. So if we take given integral as is equals to I, so our integral becomes minus pi to pi, and at the place of x we can replace x is equals to y, pi plus y over 2. So this is pi plus pi upon 2, y upon 2. This is sine 2x is equals to y plus pi, and sine this is equals to sine pi by 2, cos x is equals to pi by 2 plus y over 2 dy upon 2 upon y. So solving this, simplifying this integral, we can write this integral in the form of two parts, minus pi by 2 minus pi to pi. This is pi by 2 and this is pi by 4. This is pi by 4. Sine y plus pi is equals to this sine y plus pi is equals to minus sine pi minus sine y, and this is cos, this is sine minus pi by 2 sine y upon 2 dy over y. And again, second part of the integral is minus pi to pi. This is y upon 2 and this is 1 upon 2. This is y upon 4. So 1 upon 4 take outside the integral. So this is y, and again minus sine y. This is sine minus pi by 2 sine y upon 2, and this is y dy. This y gets out to be cancelled, and we know that the sine minus theta is equals to minus sine theta, so this is positive quantity, and this is also positive quantity. So our integral can be written as I is equals to integral from this is pi by 4 minus pi to pi. This is positive sine y sine pi over 2 sine y upon 2. This is y dy. Again 1 upon 4. This is minus pi to pi. This is sine y sine pi over 2 sine y over 2 dy. So again we write it more clearly. So this is 1 upon 4 minus pi to pi sine y sine pi by 2 sine y upon 2 dy. Again we observe that this is odd function and this is even function. So we can write this in this integral is equals to 0. So this is in 0, and this is 1 upon 4. This is by using the property of even function. This is 2 times 0 to pi sine y sine pi over 2 sine y over 2 dy. So this 2 gets out to be cancelled. Again we observe that this integral is equals to I is equal to 1 upon 2 0 to pi. This is sine y can be written as 2 sine y upon 2 cos y upon 2 sine pi by 2 sine y upon 2 dy. So this 2 gets out to be cancelled, and again this integral is 0 to pi sine y over 2 into cos y over 2 sine pi by 2 sine y over 2 dy. Again, we can take sine y upon 2 is equals to t. So this in this at y is equals to 0, t is equals to 0, and at y equals to pi, this t is equals to 1. So our integral is, and this cos y upon 2 is equals to 2 times dt. So this above integral can be written as I is equals to 0 to 1. This is sine y, this is t times 2t, and this is sine pi upon 2t, this is dt. So we use here integration by part. So integral of the given function is 2t. We take this function as first function and this is a second function, trigonometric function. Take, so integral of this function is minus cos pi by 2t upon pi upon 2, and limit is 0 to 1. So this is 0 to 1 and 2 times 2 upon pi. Differentiation of integration of this is 2 upon pi cos pi times 2 dt. Again we can, so if we put t is equals to 1, so this is 0, since pi by 2 cos pi by 2 is 0, and if t is equals to 0, this term is 0, so this term becomes 0. So this is 0, and again this is 0, and 2 to 4 upon pi, and this is cos pi by 2 t dt. This is cos pi 2 dt. Again integral of this cos is sine pi by 2 t upon pi by 2 and we take limit from 0 to 1. Again 4 upon pi, this integral is 4 upon pi to sine pi by 2 minus this is sine 0 upon pi by 2. Again this integral is I is equals to 8 upon pi square, sine pi by 2 is 1, this is 0, so 8 upon pi square. So this is the answer of the given problem. Thus we have solved the problem. So thank you.